Hey, Algebra 2. Today we're looking at problem set 21. We got two topics today. One is scientific notation, which should be some review from Algebra 1. And then the second topic is two statements of equality. Again, some review from Algebra 1. So this whole lesson should be some review. To start, we're going to look at the scientific notation. And if you recall, scientific notation, the whole process here is a way to represent really, really large numbers and really small numbers in a way that we can perform some operations. So in this lesson, we're going to look at multiplying and dividing with scientific notation. So if you look at this first example, label that number 1. What we're going to do here is first, each part of this number or of this problem needs to be written in proper scientific notation. So to start, this 5 billion, I need to put that in scientific notation. So recall, right now the decimal point is there. I need to move it way over here between the 5 and the 0. So when I put that in scientific notation, that becomes 5 times 10 to the 9th power. Now remember, that's a positive 9 because that is a very large number. Okay, second part. This one is a little different because it already has a power of 10. But if you just start with the 600, if I move that decimal over 2 places, for that 600, that is 6 times 10 to the 2nd. Positive 2 because that's a big number. So I know I'm going to have 6 times 10 to a power, but these two powers of 10, now I can put those together and make that -6 by adding the exponents. Okay, then we move to the bottom. Same idea with 30. The decimal moves over 1 place. So for just that part, that's 3 times 10 to the 1st. That 10 to the positive 1, I put that 10 to the 1st with 10 to the -5th, and I end up with 3 times 10 to the -4th. And the last one, 200 million, the decimal needs to move over by the 2. So I have 2 times 10 to the 3/8 power, positive 8 because that is a large number. Okay, really that is the hardest part of the problem, is getting everything written into proper scientific notation. From here, what I suggest you do is we're going to separate things. Across the top, everything is multiplied together. 5 times 10 to the 9th times 6 times 10 to the -6th. And what I'm going to do is I'm going to separate things. I'm going to separate just the numbers on the top and the bottom. I'm going to pull those over to one side, and I'm going to rewrite it as 5 times 6 over 3 times 2. And then times, I'm going to make, the second part is I'm going to group all the tens together. And a little tip that you can do is the tens on the top, we're going to add the exponents together. So we can save ourselves a little bit of work here. Go ahead and add those exponents as we go across. 10 to the 9th and 10 to the -6th. If I add those, that is 10 to the 3rd. And then we'll do the same on the bottom. 10 to the -4th and 10 to the 8th. If I add those exponents, that becomes 10 to the 4th. Okay, now we need to simplify this. Right here, this is already kind of in scientific notation. I have my number part, and then I have my power of 10 part. Okay, I'm going to simplify those two parts. So on 5 times 6 over 3 times 2, you could go ahead and multiply the top, multiply the bottom, and then reduce. But what I see is on the bottom, 3 times 2 is 6. That's going to cancel completely with the 6 up top, which just leaves 5. Okay, then what I want you to do on the powers of 10, every time after you've added the exponents together, I always want you to take the 1 on the bottom and move it up to the top. Okay, you need to remember what happens when you change levels of a fraction. What happens to the exponents? You should recall that when you change a level of a fraction, the exponent changes signs. So that's going to become 10 to the -4th. Okay, and when I add those together, these 10s, when I add them together now, 10 to the 3rd and 10 to the -4th, that becomes 10 to the -1st. Okay, so this final answer, I need to make sure that that is in proper scientific notation. Right now my decimal point is there, so I have one non-zero digit to the left of the decimal times a power of 10. All right, so that is my final answer. All right, let's try another one. Let's go back to blue. Same process. Take each part, write each part in proper scientific notation. So right here, the decimal moves over 1. That gives me a 10 to the 1st, positive 1. put that with 10 to the fourth, so that's 6 times 10 to the fifth. All right, the next part, the decimal needs to move way over to the other side of the 9. This is a very small number. Small numbers, again, have negative exponents, and I moved it 1, 2, 3, 4, 5, 6, 7 places. So that's 10 to the negative 7th. On the bottom, decimal moves over to the other side of 3. So 3, I moved it 2 places. That is a small number, so this is negative 2. And the last one, 2 times 10 to the negative 4th, that one is already in scientific notation. So it's ready to go. Okay, again, from here we're going to split things apart. Take just the numbers. 6 times 9 over 3 times 2. Again, if you want, you can go ahead and multiply that together, have 54 over 6, and then we'll reduce. On the powers of 10, same process. We're going to add the exponents across. 5 plus negative 7 is 10 to the negative 2nd. And on the bottom, negative 2 plus negative 4 makes negative 6. Okay, now we simplify. Again, the 3 times 2 on the bottom, that's 6. That's going to cancel the 6. So I'm left with 9. I will tell you that won't always happen. Sometimes you'll be left with some numbers. You need to go ahead and divide it out and get a decimal answer. That way you can turn it back into scientific notation. So if it doesn't cancel out completely down to a whole number like that, go ahead and divide it into a decimal, not a fraction, because we want these in scientific notation. All right, then again, on the powers of 10, always move the 1 from the bottom up to the top. Again, when it changes levels of the fraction, it changes sign of the exponent, so this becomes positive 6. And last step, put those two 10s together, 10 to the negative 2nd and 10 to the 6th. I add those exponents, and that becomes 10 to the 4th. Okay, this final answer, the decimal point is where it should be to be scientific notation, so here is our final answer. Okay, hopefully you remember that from Algebra 1. So hopefully this is just some review for you. Again, they won't always cancel out to be a whole number like these two problems did, so go ahead and divide it down to a decimal. All right, next topic, two statements of equality. These are going to be word problems, and they're going to start off kind of basic, just talking about two numbers and give you some information about those. This will lead to more challenging word problems where they give us specific information about number of items of various things. Okay, but it's going to start off just talking about two numbers. And these are statements of equality, which are equations. So out of this information, we need to write two equations. Most likely, we will have two unknown things. So we're going to have two different variables. And you can use whatever letters you want. My preference is just x and y because that is the most common variables that we see in most of our algebra stuff. So you look at this first example here. The sum of two numbers is 170. Their difference is 50. What are the numbers? So out of this information, we need to write two equations. The first one is the first sentence. The sum of two numbers is 170. All right, if I use my two variables, x and y, the sum means I add them together. X plus y equals 170. So there's one statement. Okay, the second statement says their difference is 50. Difference is subtraction. So I'm going to take the same two numbers, x and y, but this time I subtract them, and my answer is 50. So now we should recognize this as a system of equations, and we're going to find x and y. And to do that, we have a choice. We can use substitution or elimination, just like we've done in the past. A lot of times these will be set up nice and neat for you. This one is set up perfect for elimination. So I don't need to change either equation because right now if I add them together, these y's are going to cancel. Most common mistake right here, this is 1x plus 1x, that is 2x. That is a very common mistake, so please don't make that. And then 170 plus 50 equals 220. And now we have a simple equation to finish solving for x. I'm going to divide both sides by 2, and I get x is 110. So one number is 110. Now I need to find the other number, so I can go back up here, plug in 110 for x. Let's make it 110 plus y equals 170, and subtract 110 from both sides, and we get y is 60. Okay, so now you can double check your answer to make sure you did it right. If you take the two numbers, 110 and 60, those should add together to be 170, which they do. And also their difference, if I subtract them, 110 minus 60 should be 50. So both of these numbers work for those two statements. Okay? Second problem, this one I put on here because you will see some on your homework, and it's a little bit tricky the way it's set up. The ratio of two numbers is 4 to 3. Their sum is 42. Setting this up with two equations, we're still going to have two variables. Probably the easier equation is their sum is 42, so I could say x plus y is 42. Now the first statement there where it says the ratio of two numbers is 4 to 3. So my two numbers x and y, I write that as a ratio, x over y is 4 to 3. Now this is a little tricky to deal with this one. So what I would do is go ahead and cross multiply on this one, and we get 3x equals 4y. So I'm going to use this equation because I don't like fractions, and this equation, and I need to solve that system. For this problem, I would use substitution. So on the top equation, the x plus y equals 42, if I were doing the problem, I would subtract y from both sides, and I have x equals 42 minus y. So then my substitution process, I'm going to plug that in for x in the other equation. So take out x, plug in 42 minus y, and now I can solve this for y. If I distribute 3, that is 126 minus 3y equals 4y. Add 3y to both sides, I get 126 equals 7y. Divide both sides by 7, and we get y is 18. So there's one of my numbers. Now I need to go back and find x. I would go back over here to this equation that I solved for x, plug in an 18 for y. 42 minus 18 is 24. Okay, now that's the way to set it up, setting up these two equations. Another way we could do the same problem. Let me make a little bit of room here. We'll switch to red. We've done a lot with ratio boxes. So one thing we could do is we could set up a ratio box. And I'll just set this up. You should know how to solve it once we get it going. It says the ratio of two numbers is 4 to 3. So I could call this one my x, this one my y, and this is our sum. So the ratio of two numbers is 4 to 3. So what is that sum? That adds up to be 7. Okay, then it says their sum, the actual numbers, their sum is 42. So now I could plug in my variables, plug in an x up there, and use the 4 and x, 7 and 42, and cross multiply that way. I can plug in a y in that box and use 3 over 7 and y over 42, cross multiply those two. So I'll try another one of those in class to try to explain that part. But the setting up the two equations, that may be your best bet, or the box. It doesn't matter to me. Okay? That's all from lesson 21, scientific notation, and then two statements of equality, writing two equations and then solve with substitution or elimination. Okay? That's it from lesson 21. Good luck.